Hello, my name is Deepak Nulu. This is an introduction and demo of Tree-Ware. Tree-Ware is an end-to-end declarative framework for building applications and services quickly, with high quality, without AI, and without the corresponding hallucinations. This is the fifth implementation of such a framework. The first four were closed source, and I had to keep re-implementing them at every startup I went to. Luckily, the fifth implementation is open source. Prior implementations have been used in embedded systems as well as cloud systems, and this approach scales across the entire spectrum. Being an end-to-end framework, I chose Kotlin as the language of implementation because Kotlin is multi-platform and can be used on the front end as well as the back end. So what is the approach of this framework? Does it use code generation? No. It actually uses abstract algebra as its foundation. Abstract algebra is a set of elements and operators that operate on those elements and the properties of those operators. The inspiration for this was actually relational algebra. When I was learning about relational databases, what blew my mind was the fact that an algebra was being used to implement the database. The algebra being used consisted of relations or tables as the elements, and the operators are operators like selection, projection, and join. This raised two questions in my mind. Can we do this with trees instead of tables? And can we do this in layers other than the database? Turns out the answer is yes. In Tree-Ware, the elements are trees, also known as models, and operators that operate on those trees. A meta-model defines the schema for the models, and these operators use these meta-model definitions to operate on the trees. Let's take a look at a couple of examples. You are most likely familiar with Venn diagrams. In this example is an example of an intersection operator that takes in two sets and returns what's common between those two sets. In Tree-Ware, these circles represent model trees, and the intersection operator is used in role-based access control. So the first circle on the left is a user request, which is actually a model tree. The circle on the right is the role assigned to the user, and it's also a model tree. The intersection, the output, the part that's common to both of these trees, is the permitted request, the parts of the request that the user is permitted to make. Another example is the union operator. As shown by this Venn diagram, the output of the union operator is elements from both the inputs. Again, in Tree-Ware, these circles represents model trees. An example usage of the union operator is in the case of fan-in. You may get a request that you fan out to multiple services, and the responses from each of these services needs to be combined or fanned in before sending it back to the client. So the first circle here represents a model tree that is the response from the first service, and the second circle is another response from another service. And the union operator combines these two model trees to create a single model tree that is then returned to the client. So everything is a model in the system. Get requests, set requests, the roles that we just saw in the first example, and any other data, they're all model trees. These model trees then flow through pipelines of operators, and you can view the entire system as a collection of mathematical expressions that are operating on these model trees. So here's an example pipeline for a set request. All these circles in this diagram represent operators and not model trees like in the previous diagrams. So the UI is a collection of operators, and they send a set request, which is a model tree, to the backend. The backend does authentication and then uses an RBAC operator to make sure that only the parts that the user is allowed to set goes through the rest of the pipeline. Then there's a validation operator that validates the model against the meta model. And then it flows into a custom business logic operator. From there, it flows to a MySQL operator that writes the model tree into the database, and that gets picked up by Maxwell's daemon, and that operator will convert the output of MySQL into a model tree again and writes it into Kafka. And from there it gets picked up by the Elasticsearch operator and written to Elasticsearch. At the bottom is custom business logic that can again pick up this model tree from Kafka and do what it needs to do with it. Tree-Ware is still a work in progress, and this slide shows the parts that are completed. RBAC is fully complete, but it's not yet integrated. Same with custom business logic. Basic support is there and more is being worked on. MySQL is complete. As a developer of a system based on Tree-Ware, you only need to define the meta model and custom business logic. There is no need to define an API. You can get and set anything in the model. The APIs for doing that is already built in. And everything in Tree-Ware is extremely fine-grained. You can get and set a single field or hundreds of fields. Tree-Ware is built to be fine-grained from the get-go because it is easy to go from a fine-grained system to a coarse-grained system. Tree-Ware does support coarser grains as well. But it's a lot harder to go from a coarse-grained system to a fine-grained system. I would like to revisit the topic of AI. I mentioned that Tree-Ware can be used to build end-to-end systems without AI. And most of the system is provided out of the box. But there are parts of the system, shown in dashed lines in this diagram, that need to be implemented manually. You could use AI to implement those parts. AI can also be used to implement Tree-Ware libraries themselves. I'm using AI to implement an operator for writing model trees to Elasticsearch and another operator for converting search results back into a model tree. Finally, I plan to support AI in Tree-Ware. All products these days have a chatbot and agentic AI for users to interact with the product. Tree-Ware could make such a chatbot and agent available out of the box, and it would have full knowledge about the product thanks to the meta model definition. And now for the demo. For the demo, let's build something more complicated than a to-do app. Let's build something like IMDb that has structured data, images, videos, and user-entered text. There is a GitHub org for Tree-Ware, which contains a bunch of repositories. The one we will look at today is the end-to-end or E2E repository. It helps you build end-to-end Tree-Ware systems. I've already completed the demo to speed up the video. The code is in a branch called Movie Hub Demo. A link to it will be there in the video description. This is IntelliJ IDEA with the demo branch checked out. To build your own system, you just need to follow the README file. It is a combination of changes to make and things to run. I've already made the changes in this branch and I will step through them. The first step is to define the meta model. The convention is to define each package in a separate file. I have one package for people, one package for movies, and one package to define the root entity that combines them both. Each package has a name and a collection of enumerations and entities. Each enumeration also has a name and a collection of values. Each entity also has a name and a collection of fields. Fields can be of various types. I will add a link to the video description that lists all the various types. When targeting MySQL, each entity needs to have an ID of type UUID, and it needs to be marked as the key field. The key fields are like the key columns in a database. When targeting MySQL, you also need to define this auxiliary data. It helps you define overrides. For example, over here, we specify a table prefix. Tree-Ware tries to use the package name automatically as a table prefix, but as you can see, this is too long to be used as a table prefix, and so you can override it with a shorter name. There is validation in place that will tell you if the table prefix needs to be overridden or not. You can also override the entity name, which is used as the table name by default. And even when you do not want to override anything, you still must specify an empty object here to indicate to Tree-Ware that you want this entity to be stored in MySQL. The movie package contains enumeration and entity definitions for movies, and this file contains a root entity that points to movies, a list of movies, and a list of people. Tree-Ware has a custom Gradle plugin for generating things from these metamodel definitions. Let's run that here. Already run it before. The output shows up in the build directory, and in there a Tree-Ware directory. The doc directory contains OpenAPI spec. This is a stopgap measure. Eventually there will be a API navigator that helps you navigate the APIs and make set and get requests. It also generates a UML diagram as shown here. This is a lot easier to consume and to see all the relationships. You get to see the compositions that start with this filled diamond, and you have the dashed arrows for associations. The Gradle task also generates custom classes based on the metamodel definitions. This is for type safety, mainly used in custom business logic. We'll take a look at that later in this demo. The next thing to do is to update application.conf, update the name of your service, and then we need to copy over a couple of values from the main meta model file, the top level file that defines the root entity. The meta model itself has a name and a package, and we copy those over here, the name and the package. You can also set it as environment variables, but for this demo, we're just going to override application.conf. And now we are ready to run things. The first is to run the dependencies, which currently consists only of MySQL. MySQL is now running, and I have connected to it here on the right. It has only the default schemas and tables. So the next thing to do is to create the database tables for storing the model. And there is a script included that will create the tables based on the meta model definition. Let's run that. And once that completes, we should see the tables for it. Once the script finishes, you can refresh your database view, and now you'll see that there is a movie hub schema. Let's open that up, and you can see that there are 10 tables created, one for each entity that we defined in the meta model. Let's view the tables for the person and relation entities. And as you can see, there are no rows in them. The next is to run the actual Tree-Ware server with our meta model. The Tree-Ware server is not yet in a Docker container to allow for faster iterations. So I'm just going to run it from here. And that's it. We are now ready to make API calls to write and read data from our backend. The demo branch contains a directory full of API request examples. There is an environment file that points to the server and with the username and password. This is required but not implemented on the server side yet. And the environment file has to be specified in each of these example requests, the .http files. You specify it here. And let's run a GET request. And right now we get back a 200 OK, but nothing in the response. A GET request is actually a post, HTTP post in Tree-Ware, because you need to specify a body that describes what you want to fetch from the server. So it's basically the same shape as your model tree. In this case, we have a list of movies and a list of people. Where lists are involved, you need to specify what fields in the entities in that list you want to get back. So for movies, this request wants the ID and just the name of the movies. And you can go deeper. For example, for people, we want the ID, name, the birth date, and the list of relations. And this being a list, we again need to specify the fields inside the entity for this list. So here we want the ID, the relationship, which is an enum, which specifies the type of relationship, and relative is an association, which means it's a pointer to the actual person that this person is related to. Let's set some data now. The set request is also a HTTP post, and the body is again a model tree that specifies the fields and the values that we want to set. We also have an auxiliary data associated with fields or with an entity that specifies what type of operation we want to do. Do we want to create? Do we want to update? Do we want to delete? Since we have no data yet, this is going to be a create. We're going to create two actors, Tim Robbins and Morgan Freeman, with these birth dates that I got from IMDb. I intentionally used the wrong year for Morgan Freeman so that we can fix it in an update request next. So let's run this. Oh, we got a 200 OK. Let's go take a look at the database tables to see if it actually said anything in the database table. So if we refresh it, we got 2 rows, one for Tim Robbins, one for Morgan Freeman. We did not set any relationships yet for these two actors. So if I were to refresh this table, there's nothing in there. And now let's rerun our GET request. And now we get back some JSON, which is basically what we set, Tim Robbins and Morgan Freeman with the wrong year. Now let's send an update request to fix this year and make a few other changes. In this request, we're going to update this entity with the correct year for Morgan Freeman using Morgan Freeman's ID. We're also going to add a brother for Tim Robbins This is the relationship. We are creating the relationship. This is the ID for Tim Robbins, and this is the association to his brother. And as you can see, this is also the same tree model because the pointer starts from the root of the tree. And followed by, we're going to actually create David Robbins as the brother for Tim Robbins. As you can see here, we first point to an object that doesn't exist yet, and then the object exists later in JSON. Tree-Ware figures out the proper order to create these things, so you don't have to worry about it. Let's go ahead and run this. We go back at 200 OK. Now let's look at the relations table. We've got a relationship, and if we look at the people table, the person table, now we have David Robbins as well. Let's go ahead and make a GET request now, where we wanted these relationships and previously we were not getting it, and so now we should get something when we run it. And sure enough, here's that relationship that we just added. One thing I wanted to point out about the request that we just ran, it is a mix of an update. We did an update here, but we were creating a sub-object in an existing object, and then we were creating a new object. So you can do a mix of various operations in a single request, including a delete. Speaking of deletes, that's next. What we're going to do here is we're going to try and delete David Robbins. And we expect this to fail because Tim Robbins is pointing to his brother. So if we were to run this, we get a 400 bad request with an explanation saying that path that we are trying to delete, we're not able to delete it because it either has children, parent cannot be deleted if it has children, or it is being pointed to by an entity. So what we have to do is another request that deletes the relationship or the association that points to the object we want to delete. So in this request, we are deleting the association to the object we actually want to delete. And as you can see here, the order is again in a different order than the actual deletes. Tree-Ware is smart enough to figure out the proper ordering for you. So if I were to run this now, we should get a 200 OK. And if we go to the person table, we shouldn't see David Robbins anymore. And then if you go to the relationship table, we shouldn't see the relationship entry either. And if we run the GET request once again, we see that the relationship is not part of the response anymore, and we only have two people, Tim Robbins and Morgan Freeman. I rushed through these APIs to keep the video short, but all of these requests are available in the demo branch, and you can play with them and look at them slowly to understand the structure of the requests. They're identical to the trees that were defined by the meta model. The meta model allows you to specify a lot of different types of constraints on the model, and Tree-Ware will automatically validate set requests to ensure that the constraints are not violated. But you may need to validate constraints that are not yet supported by Tree-Ware, or you may need to update the set request based on certain business rules. Both these requirements are supported by Tree-Ware, but it requires you to write code to interact with the model in the set request. This is where the generated model classes come in. They provide you type-safe access to the model in the set request. Let's take a look at that now. You need to implement your business logic and classes that implement this interface, and then you return instances of those classes in this function. By default, this function returns an empty list, but it has been updated in the demo branch to return an instance of this class. Let's take a look at this class. As mentioned before, it needs to implement this interface. This interface requires you to specify an input shape, an output shape, and an actual invoke function that gets called when a set request happens and your business logic function needs to execute. The input shape specifies which parts of the model you're interested in validating or interested in applying business rules to. The output shape declares what you're going to do. If If the output shape is null, it means your invoke function is just a validation function and you're not going to modify the set request. If it's a non-null value, which is just an entity model or a model tree, then it declares which parts of the set request your invoke function will modify. These two things will eventually be used by Tree-Ware to provide build time and runtime safety to ensure that your invoke function only does things that it says it will do. In the implementation that we have, we want to validate the name of a movie to make sure, or a name of a person in this case, to make sure that it is not an empty string. This is a validation that is actually supported by the meta model. It's just a declaration in the meta model, but for demo purposes, we are going to actually implement it as custom business logic. So the input shape has to be specified. So we are saying, again, it's from the root, and we are using the generated DSL to specify the model tree and the elements we are interested in. And as you can see, the DSL provides a JSON-like syntax. So the root is the movie hub, and in there we're interested in the people list, in that we're interested in a person's name, and the ID has to always be specified in the case of data being stored in MySQL. So this is the input shape we're interested in the names of people. And so whenever a set request contains a name of a person, it's going to result in this invoke function being called. And this is purely a validation function, and so the output shape is null. And in the invoke, you can actually return errors, and if you return errors, then you can either return a response success or you can return a response error. And if you return a response errorless, then or an error model, then the set request will be rejected and your errors will be reported back in the response body. So here we could, since the set request is a bulk request, it might be setting one or more people. So we have to iterate through the list of people and then check if the person's name is an empty string, then we create an error. Tree-Ware will eventually make this a lot easier to create these errors, because you can either send a list of paths and for each path what the error is, or eventually you'll be able to send back a model tree with auxiliary data for the fields that have errors. Right now it's a little cumbersome to use. We are using the generated type safe classes, but a lot of this is going to get easier over time. So let's run this now and see. Let's run a set request that has an empty name and see that we get back a name is empty error. The directory of API examples contains a request with an empty name being set. We're trying to create a person with an empty name. Let's set the environment for this request and run it. And as you can see, it's getting that error in our custom validation saying name is empty. And if we refresh our list of people in the database, we don't see that entry. Let's go back to this request and set some name. This date looks like a Y2K date, so I'm just going to call the name here Y2K and run that again. And this time we get a 200 OK. Let's go back to the database. We see that entry here. And that's it for this video. Please check the video description for links. Thank you.